So this is logistic growth we're going to look at. And logistic growth is related to exponential growth. And remember, the recursive formula for exponential growth is some new amount can be found by taking a look at the previous amount. And there's two versions of this. One is to take the previous amount and then add the growth rate times the previous amount. Right? The other version is to use the gross multiplier, which is the 1 plus R. So I'm going to look at this one for a second. What logistic growth tries to look at is to say, well, if you do this, this grows forever and it gets steep. Once it starts to grow steep, it just gets worse and worse and worse. And that's just not sustainable. What happens is things reach boundaries, boundaries with food, boundaries with disease, boundaries with area, boundaries with predators, whatever. And so logistic growth says, well, the R can't keep the same the whole time. And so the idea someone came up with is, depending on, there's got to be some limit to the population. So if we can guess what the boundaries say, then we can guess how things might grow. And to do that, we have to have what's called a carrying capacity. And this is one of many ways to try and figure out how constraints restrict population growth. Capacity. And we call that K. Why K instead of C? I don't know. Somebody picked K. And what we do is the growth rate, right? Eventually we do a 1 plus R to deal with that in exponential. The carrying capacity is going to reduce that. So we're going to do a 1 minus as a multiplier. And the rate that's going to restrict is whatever the population's at now compared to the carrying capacity. What fraction of the population to the carrying capacity are we at? Take that away from 1, and that's how we'll adjust the population growth, is the way that works there. Right? So this is our formula, and we have to apply the previous population 1, 2, 3 times. So the situation I'm going to use is a stocked pond with trout. And we're going to say the initial stock in the pond is there weren't any trout in the pond, and we started with 40 trout. And it's a small pond, like around here, my favorite small pond is Indian Lake up in the mountains. And let's say it can sustain 1,000 trout. So the pond can sustain up to 1,000 of these trout. After that, it's too many, and then disease is going to be a problem, and food for the trout's going to be a problem. It's just too many for the pond to handle. And then if there wasn't any cap on growth, so absent constraints, we believe the trout would grow at 30% per year. So what this gives me here is my P0 is going to be the 40. The 1,000 is my carrying capacity, and my R is 30%, or 30 divided by 100, which is 0.3. And if you need to do this a bunch of times, the easiest way to do it is on a spreadsheet, because on a calculator, you got to retype this whole thing every single time you want to do a new calculation, which isn't bad, but it's, you know, a bunch of buttons to push. So I'm going to show you how to do it in a spreadsheet first, calculator second. So we're going to set this up in a spreadsheet, and I'll share the spreadsheet. For those of you in class, I just put it in the announcements. If you're looking at this in a video later, it is in the description of the video. So I want to add a new page. We'll call this Trout. And things I need to keep track of here are really just whatever period I'm in. So the year, which is my N, and the number of trouts. And I'm just going to make a note out to the side. My growth rate is 30%, and my carrying capacity is 1,000. And I find it, I'll just show you two different ways. So let's check it out. So 0, we're starting with 40 trout. And in the next year, I'm going to run through that formula. So the formula says equals on a spreadsheet, take the previous amount and then add to that the growth rate. Now, instead of clicking on the growth rate, I'm just going to type it for now. It's more complicated to click on it. I'll show why in a sec. So I'm just going to type the 0.3. And then I want to multiply that by the previous amount. And then that's exponential growth. That's not what we want. So I need to multiply that again by that 1 minus the previous amount, which is above, divided by the carrying capacity. And again, because the carrying capacity is not in the same column, I'm not going to click on it for now. I'm just going to type it. I'll show you how to use it in a click, but that's more complicated. All right, so that's my formula. Previous amount plus the growth rate absent constraints times the initial amount or previous amount, and then times parentheses 1 minus the ratio of the previous amount over the carrying capacity. And once I have that, I can just fill it down. I don't need to type it again, which is kind of cool. And so over here, I can fill those down. Reminder, when you fill down a formula like this, you only need one instance of the formula to fill down. You don't want to grab both of them. That'll screw stuff up because this is a number, that's a formula. I just want to fill the formula. So after I do it, I click back on it. Then I point to the fill button. Then I click and drag down. These are just numbers. I want to continue the pattern. So I have to select the pattern, then let go, then grab the fill button and fill it down. And I can just do this forever. Now, once I have a couple of them with the formula in it, notice when I click, it shows the formula above. Now I could fill down 2 of them because they're both formulas here in both numbers. So that together I could fill those down forever until the spreadsheet says stop. I can't do anymore. Too many decimal points, that's hurting my head. So I'm going to highlight the whole column and decrease. Let's just do 1 decimal point. You can't really have a fraction of a trout. These are just calculations. So I could get away with just a whole number, but the homework might ask for 1 decimal place. So I'm just going to do that there. So I can answer anything. Now, what I can't do easily here, I can't on paper easily say, when will this population double or triple or whatever? The only way to calculate that is on a spreadsheet, or if you learn more about logistic growth, which we don't have time for, we need another week for that to figure out how to solve a logistic equation. They're way more complicated than exponentials, as you can see. All right. So some of you may have been wondering, like, why didn't he just click on those numbers there? So that's more complicated. I'm going to show that next. So I'm just going to delete all those numbers. Start over. If I want to use those, I can. So I start again with the initial population or previous population, add to that the rate times the initial population. That's exponential. To make it logistic, I do times parentheses 1 minus the previous population over the carrying capacity. Now, if I fill this down, I'm going to get very different numbers. Check this out than before. I should have left the other numbers to see. Oh, division by 0. What the hell? Why did it work before and not now? Here's why. When the B2, right, that's my previous amount. When I fill that down, don't I want it to switch the B2 to a B3 and then the B3 to a B4? However, it's also trying to shift these down. So in this one right here, it's trying to find the rate here and the carrying capacity there. In the next cell, it's trying to find them down there. So anytime you shift a formula, it tries to shift the cell references also. To tell it, no, don't do that, you got to sneak in a little bit. So let's blow this up some more. So you can, that might be too much. double click in there. All right. So the B2, I always wanted to grab a number above. That's good. The orange is good. Your spreadsheet may have it colored different. The E1, the key there is I always wanted to look in row 1 when I fill this down. To tell it to not to screw with the 1, I just sneak a $ in front of the 1. So when the spreadsheet reads across this to make a copy of it, it sees the $ and it says, whoa, don't touch the 1. You might say, well, why not touch the E? I'm just filling it down. When I fill it down, it only wants to change the row number. If I was filling left and right, it would want to change the letters. Then I would say, whoa, don't touch the E. So it doesn't matter whether I put a $ in front of the E or not. The 1 matters because I don't want it to change row 1 to row 2 for the percent. It's always in row 1. Same thing for the carrying capacity. That's always over here in row 2. So I need to put a $, say always, oops, $, say always look in row 2. Now when I copy this down, it'll change the B2s, but not the E1 or the E2. So let's just check, hit enter, click back on it, grab that fill button, drag it down as far as you want. Now it's doing good stuff. So I should see that in the next one, it has now B3s with E1 and E2. The next one should have B4s with E1 and E2. So now it's behaving correctly. So again, if you do grab numbers that don't change, you got to make sure to $ the right part of that cell reference to make that work right. All right. Now, anytime I use a spreadsheet, I usually do a couple of things to make sure I use the spreadsheet right, especially if it's the first time I've done something on a spreadsheet. Thing number 1, I always write it on paper first, and I kind of wrote it on paper here. So far what I wrote on paper is I wrote the equation I'm going to use and the numbers I need to plug in, but I didn't actually write anything with numbers. And so I usually at least write the first step or 2 with numbers, check it on a calculator, make sure I did it in the spreadsheet right. So P1 for me is going to be 40 plus 0.3. What's up?
Isn't it P0?
P0 is the initial amount right here. So I'm calculating P1. To calculate P1, I need P0. So it's always the previous number that goes here. Yeah, so here my P1 is what I want to find, and I need to use P0 to get there. So I'm going to have R times P0 here. So I'm going to have another 40 there. And I'm going to have times parentheses 1 minus P0 over K. So for me, that's going to be a 40 over 1,000. So I want to type this into my calculator, make sure it agrees with my spreadsheet. Notes. So 40 plus 0.3 times 40 times parentheses 1 minus 40 over 1,000. Oops, one place. And that says it's 51.52. I do remember seeing that number in my spreadsheet. Yep. Show more decimal places. There's the 0.52. So the calculator and the spreadsheet agree. Chances are my spreadsheet's probably right for the next few. If you're not sure, double check. And again, the spreadsheet gave me a big error before. Divide by 0, boom, my computer exploded. And I had to refix that. So that usually if you have numbers that are used over and over again, the easy thing to do is just instead of cell reference them, just type them in manually. That's logistic growth. Let's look at the graph of this. So let's see, let's add a couple more years. I got 25 years of data here. I want to see what that looks like. Anybody remember from the last class what the shape of a logistic graph is usually going to look like?
Yes.
It's an S shape. Yeah. So let's see if I have enough data to see the S shape. And again, spreadsheets, graphs are easy. You just highlight the points, click I want a chart. It guesses, it guesses I wanted a bunch of points. And I think it did a pretty good job. I got enough years. Yeah, that looks like a pretty good S shape. You can see it starts off looking exponential. And then all of a sudden the data about the carrying capacity kicks in and the population starts to slow down growth until it starts to stabilize near the carrying capacity. And in reality, what happens is if it's left alone, it'll oscillate up and down near the carrying capacity. Unless it drastically overshoots it, which can happen too. Because it takes a little while for the population to realize, oh shit, there's too many of us. We're going to die. All right, logistic growth, fun stuff.